to execute code. So I may try to upload a Swift to take advantage of the same origin policy and get to interact with the browser via JavaScript. Or I may try to upload that Swift to get permissions, to get cross-domain permissions to attack another site. And if you wanted to see an example of that, Jeremiah Grossman wrote a blog about attacking YouTube by sending himself an email attachment to his Gmail account that was a Swift. So the way it worked was youtube.com trusted star.google.com. So, and he wanted to attack youtube.com. So since he didn't have a vulnerability against youtube.com, what he did is he emailed himself a malicious Swift to his Gmail account, which allowed him to get the Swift onto gmail.google.com. Once that malicious Swift was on gmail.google.com, it had cross-domain permissions to call into youtube.com. So you want to be careful anytime you're obviously allowing end users to upload content to your site. And identifying Swifts are fairly easy if you're doing filtering on the upload. It'll either begin with FWS or CWS. So be careful of that. Another thing to keep in mind when you're doing web application penetration tests is that automated web scanners have differing levels of support for being able to understand Flash content when it's crawling the site. So if you're using Sensic or WebInspect or AppScan or any of those type of tools, NT objectives, they all have differing levels of support for how they handle Flash content. And if you have Flash content that's a form, then those tools may not see the server CGI addresses that are behind those Swifts and that those Swifts are calling, because the tool may not be able to understand that Swift, so it skips over it, or it tries to grep the binary for the URLs, but it doesn't actually understand how to interact with it at the same level it does HTML. So that's something you want to be careful of. Like if you're a site that has a shopping cart built completely in Flash, depending on the level of Flash support within your automated web app tool, it may not exercise all those CGIs that happen during the shopping cart process because the automated tool just doesn't understand it. Now, all the vendors have been working towards improving their support, so most of them have some level of support for Flash content, but it's something you want to be aware of. And you just want to double check to see if the tool is able to find all the functionality that you were expecting it to test. In most cases with these tools, if you just do a manual explore, then the tool will be able to automate, record all the requests during the manual explore and then do its traditional penetration testing techniques after that. But it's something you want to be aware of when you're using these type of tools on sites that have Flash content. Another thing that's been recent research is a protocol or a format we use called AMF. It's the action message format. And basically all it's used for is to serialize data between the client and the server. So if the Swift has an object which represents a person, first name, last name, address, etc., and it wants an easy way of sending that to a Java backend where another object that also represents a person gets populated, AMF serializes that information into an intermediary format that they both can communicate over and allows you to send objects across the wire. In the past, AMF support has been limited in web app pen test tools because it was binary and the tools just didn't understand it. But a lot of the tools actually now support AMF and the ability to actually understand what's inside that binary blob. So AppScan, WebScarab, Burp Professional, Charles Proxy. If you like using Fiddler 2, there's an AMF parser plugin for it. So the ability to actually manipulate those data values that are getting sent to the server is increasing within those tools. And it's important to be able to test those because if you're looking for SQL injection within the object person, you want to be able to manipulate all those individual fields. Also, there's been tools that have been generated for testing the AMF server that's receiving these. TrustWave Security made a tool called the Blaze, and it tries to enumerate the AMF services that are at the server so you can figure out what the server is providing as far as services. And then Gotham Digital Security created a tool called Blazon2, which looks for AMF servers which act as proxies to backends inside the internal network. So AMF is no longer this sort of binary thing that people didn't understand. The amount of research that's out there for it is actually increasing, and Adobe has published a spec for that format for both AMF0 and AMF3. If you want to actually learn how to use these tools and you're interested in doing AMF testing, they published blogs which explain the tools and how to use them. In addition to explaining Blazon tool, Gotham Digital Science also posted a blog on writing custom AMF tools. So if you want to write a Python or a Ruby script that does manual pen testing for your specific application, he sort of talks about the libraries that are available for that if you want to attack the AMF server. And then the Blaze was presented at DEF CON, and there's a good 20-minute video explaining the tool. It's nice, it's short, he gets to the point, and he has a pretty good demo with it. So if you're interested in AMF and your web applications are using AMF, you may want to take a look at that. And lastly, just a little bit about cross-domain policy files. Basically, what cross-domain policy files allow is they allow access to the body of the message that's returned from the server. So a lot of you are familiar with cross-site request forgery, and the way the attack cross-site request forgery works is you send a series of requests to a domain that's not yours, and you're sort of flying blind. You just send the requests hoping that they work. So if I'm on example.org and I'm attacking paypal.com, I just go and I send a series of post requests to paypal.com in the right order, and I hope they all work and as an attack. And the reason why you're flying blind is that the same origin policy prevents you from seeing the body of the response that comes back. So what cross-domain policies files allow you to do is it actually allows you to see the body of the response that comes back. And there's legitimate reasons for needing to be able to do this. A lot of times people are using it because the SWIFT on images.example.org wants to be able to talk to the domain www.example.org. So they're using it for just communicating across subdomains to allow their load balance site to be able to communicate across the subdomains. It does not provide access to the headers of the request. It only provides access to the response body, and doesn't allow any sort of code execution. It's solely about whether when you do a GET request to another domain, can you actually see the body of the response that comes back? And the policy file is hosted on the site that owns the data. So the site that actually owns the data that's going to be read gets to say, okay, I trust this other domain to be able to read it. I don't trust this domain to read it. So it's a whitelist of which domains you trust to be able to read response bodies that come back. And typically a cross-domain policy looks like this. The first line says there's only one cross-domain policy file on the server. The second one says which domains are allowed to read the response bodies back. So it can be a full domain, it can be an IP address, it can be star.example.org, it can be star. And then the third line is whether or not the site that hosts this cross-domain policy file will receive custom headers from any other domain. And I'll get into this a little bit more tomorrow in my talk on cross-domain communication. But the important things to keep in mind are the things you tend to hear a lot when people talk about cross-domain policy file. A wildcard star value will allow everyone to be able to read your content. This can be dangerous if your site uses session IDs and URL links, because if your URL is appending the JSession ID within the body of the response, that means the JSession cookie value is being sent back in the body of the response where the SWIFT can read it based on the cross-domain permission. You obviously want to avoid them in any site that uses SSL or requires a user login. If you're requiring a user login or SSL for the site, chances are you didn't want to share data with other people. That's why you have the SSL connection set up in the first place. So If you have a site which has a star permission, you don't want to use it on sites that, you typically don't want to use it on sites that use SSL or require a login. In some edge cases, it's probably okay depending on your use case, but as a general rule of thumb, it's a bad practice. And if you do need to allow star permission, you don't have to open up the entire website. You can actually open up a directory within that website, and you create a directory called public, and then you put the wildcard permission restricted specifically to that directory by putting a specific cross-domain policy file in that directory. That way, you only expose the directory which is public, and you don't actually expose the entire website. A lot of people will just put star in the root cross-domain policy file, and that's where they run into trouble. So overall, these are sort of the basic things that you're looking for. Obviously, I could keep going. I've done an hour and a half version of this before. But if you're looking for information, or some of these things that seem like things you want to look into deeper, the OWASP Flash Security Project is available. All the links I referenced, all the research I talked about during this presentation, it's all referenced there. You can go, you can find it. You can read the original sources that I'm citing to get more information. The Adobe Developer Center has information for Flash developers. It talks about the changes we make in within Flash Player from release to release to make the model more secure, whether it'll have backwards breaking changes, new APIs which are introduced. And if you're interested in Adobe Security in general, there's an Adobe Security section. But in general, as long as you have secure practices around how the Swifts are developed and you know what to look for and you know what to test for, you can deploy Swifts safely. Most of the information that you already know about web application penetration testing can apply to testing Swift content. A lot of it's just dealing with the fact that it's a slightly different language. But overall, it's still a part of an overall web application, so you need to take a look at it within its complete context.